Hello, I'm Jack. Welcome to Practical Programming channel. In this video series, you will learn everything you need to get started with WebGPU Graphics Programming. In the last video, we discussed how to create a 3D sync surface chart with both color-mapped surface and a wireframe on the surface. In this video, I will use the same framework to create a simple 3D surface based on peak mass function. This is the peak surface chart. You can see very pretty chart. Here we will use the Git tool to clone the source code used in the last video. Here is the download link at GitHub repository. From this link, you can download all the source code used in the last video. Now, let's start the Visual Studio Code directly from Windows Start menu. Visual Studio Code. This is a Visual Studio Code interface. You can close this start page. Now, let's start a new terminal window and cd into code folder. Inside this folder, we create a new folder called GPU44 made directory GPU44. So this new folder was created successfully. Now cd into it 44. We can then clone the source code used in the last video with the command git clone WebGPU 43. After this, we have a space, then period. This will place our source code in the current folder. Run this command. Okay, the clone finished. You can check. You see all the source code already in this directory. Now we can open this folder from Visual Studio Code. Open folder from code GPU44. This folder here contains all the source code used in the last video. Now close this start window and open a new terminal window and use the npm install to restore the npm packages used in this example. Okay, finished. Now all the installed packages are stored in the node module folder. Today we want to create simple 3D surface chart for a peak function as shown here. You can see this is the definition for our peak function. fxz, this is peak function definition. Previously we have defined this function in the mass_func.ts file. Next, we need to make some changes to the index.html file. From DRST folder, open index.html file. First, we need to change the title from 43 to 44 because this is the 44th video. Here, we also need to change the H1 title from sync surface chart to the peaks chart. Here we will use the same parameters as was used in the last video. You can see this is a drop-down menu. Lets you select different square image for our wireframe. You can see here we have 10 different square image to choose from. Here is a drop-down menu. Let you select color map. This drop-down contains 11 color map names we defined in the color map data.ts file. So we can save this file. Next, we need to make some changes to the main.ts file. From src folder, open the main.ts file. Since most code for render pipeline and render path have been already included in the chart.ts file, so here the main.ts file becomes very simple. Here we first introduce the create chart with texture from chart.ts file. We then introduce the simple surface data from surface data.ts file. We also, from mathfunc.ts file, introduce the sync function. Here we need to change to peaks function. Next, we create a new function called createChart with some input arguments. Here, the texture file parameter lets you select different square image for creating the wireframe. The color map name arguments let you specify color maps for our 3D surface. Inside this function, we call simple surface data function. Here we have a sync, so we need to replace this sync with our peaks function. And also we need to change the value range. So we need to replace this code by the peaks function here. And also we change the value range for the peak function. This function will generate the vertex, normal, color map, and UV data. We then call the create chart with texture to create the peak surface chart with balls, color maps, and wireframe. The rest of the code here is the same as that used in the last example. Here we define the default square image using the white square. The default color map name is set to jet here. So then we call create chart function to create a 3D peaks surface chart with default color map and wireframe. This part of the code allows the user to recreate the peak surface chart with different color map and wireframe by selecting them from the tool drop-down menu implemented in the index.html file. Now we finish the modification to this main.ts file. Now we can save this file. Up to now, we have finished all the programming. We can then run the following command on the terminal window: npm run prod to bound our TypeScript files. Okay, bound file is created successfully. Now we can click the Go Live link to open Chrome Canary to view our peak surface. Click this link. Here is our peak surface chart with the default jet color map and white wireframe displayed on this page. You can see our 3D surface chart looks very nice and pretty. Here we can change the color map. For example, this cool HSV hard and so on. You can select any color map from this drop down. We can also change the wireframe. This is white. We can change it to red, green, and blue, and black. Of course, for the black, you cannot see any wireframe. So let me go back to red, for example. Here, wireframe depends on the underlying color map. Particularly, a black image totally disappear from the surface chart. We have explained the reason for this issue using our Cedar code in the last video. Even though we cannot get a wireframe with pure color except for the white, we still get a nice look 3D surface chart with our square texture. Plus, we can easily change the line thickness of our wireframe by replace our square image with different line thickness. If we create our wireframe using line primitives, the line thickness will be fixed to 1 pixel because currently the WebGPU does not allow you to change the thickness of line primitives. Now we have completed this example. In next video, we will create a 3D parametric sphere surface chart. Most examples presented in this video series are based on my recently published book, Practical WebGPU Graphics. From this link, drsu.net.com, you can see the details about this book. I have created a GitHub repository to host the source code used in this video series. From this link, you can download the source code used in this video series. I also created a live demo at this link. This demo shows the live results by running the example projects presented in this video series. I will end this video here. See you next time. Bye.